Okay, so last time we were trying to prove the following fact. So let me just briefly remind you. We have a homotopy and we have a covering space. And let's say we have a lift of what? Of Fs, which is Fs 0. Then there is a unique lift F tilde to, so that was the statement. Let me draw a picture for this. So we have I cross I here as T, and we have our homotopy to Y, and here we have X covering space, and we have so-called F little tilde lift of the following. So we have on this edge we have F, and we have F tilde lift of this little f. Okay, so P composition of this is F. Then the statement is there is a unique lift F tilde, so that of course P composition F tilde is F. And how we defined this function? We defined it this way. We used actually curve lifting. We did the following. For any fixed S, we look at this line segment. That line segment gives us a path here. Okay, let me just call that path, for example, gamma S. So what is gamma? No, yes, gamma ST. This is just F restricted to that line segment, which is ST. Okay, S is fixed, T is the parameter. So I have a lift. But on the other hand, I know that this point is mapped via F tilde to a point here. So what is this point? This point is just F tilde of S, okay? It is the lift of, it is a lift of this point. And then by part A, we proved last week, we know that this path has a unique lift starting at this point. So we have this so-called gamma tilde S. Okay, so gamma tilde S T is so that this is just gamma ST. And then we define our F tilde ST as just the image of gamma S at T. Okay, so that's the definition of F tilde. This is the existence part, and then we used the again uniqueness part of part A. uniqueness part of pad lifting result or lemma, and that gave us the uniqueness part of homotopy lifting. The only thing that was left to finish the proof of this so is the continuity of tilde. So the only thing we need to prove is the continuity of f tilde. Here we define f tilde using this, curve. And it's lifting, and it is not clear at all why this gadget is continuous with respect to both parameters. It is clear that it will be continuous with respect to t because it is the unique lift of gamma st. Gamma st is a continuous path. Its lift is continuous. We proved it last week, but it is not clear why this gadget is continuous with respect to both variables. Okay, that's not clear. So that's what we are going to do. F tilde is continuous. That's okay. Now for any fixed S in I, we can choose open subsets U1, UN in Y, and the partition of the interval 0, 1. So T0 is 0, and then I have T1, T2 up to Tn, so that of this interval 0, 1, such that, or so that, whatever. We have two things. First, f tilde of this ti minus 1 pi is mapped to ui, I from 1 up to n, and each ui is a open set for the covering, so that this inverse image is a disjoint union of open subsets of X, each of which is homeomorphic to UI via P. Yani şunu diyoruz. Şu interval'ı I can divide this into pieces, n pieces, well, for some integer. Okay, so like this. Here I have, let's say, Ti, so that each of these intervals are mapped to one of these open sets. Okay, so here, let's say I have Ui, and this Ui is so that inverse image of this open set UI is a disjoint copy of this UI. So I have several copies here, and each one is homeomorphic to UI. Okay, I can do that by the definition of covering space. Yani isterseniz şöyle bir daha resim çizeyim. Şurada Y var. Bunu open setlere böldüm. Şurada bir yerde UI var. UI'nin inverse imajı bu UI'ye homeomorfik setlerden oluşuyor. Burada da bunu parçalara bölmüşüm. N parçaya. Şurada TI plus 1. Şurası işte şu UI'nin içinde kalıyor. Başka renkte yapayım. Okay, something like this. Okay. Şeyde let WI inverse image of F inverse image of UI under F. So F is this function. F is this function. I take the inverse image of this UI under F. Okay. So okay. Şimdi şöyle diyeyim. Bu so for any fixed S, I had this gadget, right? We fixed some S, and then we look at the image of this gadget here. So gamma ST, if this point is ST, gamma ST is this curve, and here we have this UI, and then I look at inverse image of this UI under F. So that will be an open set here that contains this point. So this is WI. Of course, I can do this for every point, T, for every T. Since this interval is compact, okay, since what is this interval? That interval is just S cross 0, 1, right? Is compact. We can cover by finitely many WIs. Say şöyle olsun. Şimdi her bir UI için bir tane seçmiştim. W1, WN, right? I have n many UIs, and for each UI, I just pick one WI, and I can do this. All right. Again, by the compactness of I can choose some R. Ha, şunu yapabiliriz. Okay. All right. By the compactness of I, herhalde i'nin kompakt olması orada önemli olacak. We can find some R positive. Aslında RS demiş galiba ama neyse şöyle diyeyim. RS positive so that S minus RS, S plus RS cross I lies inside W1, Wn. So what I mean is the following. Now for each point here, so each of these points is contained in one WI. Some WI is like this, some of them is like this, maybe some of them is even smaller and so on. But finitely many of them, n of them, contains this whole interval. What we are claiming is the following. I can choose some interval around this point, something like this, so that this whole band, so here this radius is RS, okay? So this whole thing is contained in this union, okay? So not just S cross I, but I take an interval around S, that interval times I, okay? So this interval is S minus RS, S plus RS. And then I cross it with I, and that's contained in this union of open sets. Tamam mı? This actually fact is called tube lemma, okay? Uh-huh. What can't happen? Okay, well, what you do actually is the following. Yeah. Yeah. Yani şöyle, so each point, as you said, is contained in some ball. And in this ball, I can find some tube like this. But, you know, depending on the point, of course, the radius you choose might be different. But we know that since this is compact, finitely many of these gadgets cover the whole interval. And then since there are only finitely many, you can just choose the minimum of them. Okay, that's the idea. Demek onu göstermemişim. Yani burada şunu söyledik. Her birisi etrafında bir tane yuvar seçip şöyle bir şey şerit seçebiliyorum. Bunun içinde kalacak şekilde. Bazıları dar olabilir, bazıları geniş olabilir ama sonuçta sonlu tane var. Her birinin içinde seçtiğim şeridin yarıçapın minimumunu alıyoruz. Peki, tüplama böyle. Okey. Bana bakıyor değil mi bu? Tamam. Note that for any fixed S, the unique lift of the path T is mapped to F S E, which is F tilde ST, can also be constructed by patching the paths T is mapped to P inverse restrict to UI FST I from 1 up to n. Yani şunu söylüyoruz. Neyse, şu cümleyi de yazayım, ondan sonra resim çizip açıklayayım. Finally, since both P inverse of P inverse restrict to UI and F are continuous, F tilde restricted to WI is continuous. And this finishes the proof. Yani şunu söylüyoruz. So what we are doing is the following. How did we define F tilde? So I had this F and then F tilde. To define F, we used for any S, we looked at this and its image is, let's say, gamma S T, and then I looked at its unique lift gamma S tilde T, and we defined f tilde to be just this value, okay? The value of gamma s at t. What we are saying is the following here. We could just define f tilde as follows. Here we have now some tube here, and each of, so, and this is contained inside some wi's. So here I have this ui's, and say this is ui, and this ui has pre-image wi here, and okay, so above this ui there is an open set here, and p is a homeomorphism here. So this is p restricted to ui is a homeomorphism, and then by the uniqueness of lifts and so on, we can say the following. You know, our lift, which is defined here, has neighboring lifts. Those lifts just lie here, and since this is a homeomorphism, you know, we have this lifts here. So all these lifts are actually just the image of this lifts via the homeomorphism P inverse. But F is continuous and P inverse going this way is continuous, and this composition is equal to F tilde. Therefore, F tilde locally can be given as F composition P inverse, and since they are both continuous, F tilde is continuous. Here, of course, we are making use of the fact that, you know, each of these paths has unique lifts and so on. Starting, you know, given the initial point of the lift, they have unique, they are unique. Şunu biliyorum, bu tübün tamamı şu UI'nin içinde kalıyor. Yani ilk önce şunu biliyordum, sadece şu parçası, yani S'teki parçası bunun içinde kalıyordu. Ama artık şey biliyorum, tübün tamamı bu UI'nin içinde kalıyor. Dolayısıyla hani şundan birazcık şöyle sağa sola gittiğim zaman hala bu resmin içindeyim. Dolayısıyla da P inverse'ü kullanabilirim. İlk başta şeyi bilmiyorum. Hani tamam, şu pet bunun içinde kalıyor ama birazcık kenara gitsem hani continuity için, o onun içinde kalıyor mu ondan emin değilim. Tamam, belki dışarıda kalıyor, o zaman da P inverse'ü kullanamam. Ama şimdi şunu biliyorum. Şu tüpün tamamı bunun içinde. Ve bu homeomorfizm, o zaman bu resmin aynısı burada var. O zaman bu liftleri F tilde'yi tanımlamak için kullandığım liftleri direkt buradaki liftlerin bu projeksiyonun tersiyle elde edebilirim. Çünkü bu lokal homeomorfizm. Burada homeomorfizm. Şu resmin aynısı bu. Tamam mı? Yani garanti bu kompaktness'ı vesairenin bize verdiği şey sadece şuradaki line segment değil, onun bir civarı da tamamen bunun içinde kalıyor. Öbür türlü şeyi gösteremezdim. S'e göre ben continuous olmasını istiyorum. Yani bu F tilde ST şey ya, gamma S tilde S. bu S'e göre continuity'yi verebilmem için, söyleyebilmem için hani şu S'deki olayı sağına soluna bunu taşıyabilmem lazım. Ama tüplama yoksa onu taşıyamam. Hani çünkü birazcık kayınca belki resmin dışına çıkıyorsun ve bu şeyi kullanamazsın. Nasıl? İşte iCross R'da sıkıntı çıkabilir. Ha şu mesafe burası kompaktsa sorun yok. Evet, evet, evet. Burayı istediğim kadar uzatabilirim. Orada sorun yok. Şu yukarıya giden kısmın kompakt olması önemli. Evet, evet. Tüplamanın statement'ı o değil de tüplamanın söylediği şey o. Tüplamanın ne olduğunu söylemedim zaten. Yani herhalde şimdi oturup ne söylüyordu o bir tane çarpım uzayı varsa I cross J diyelim ya da X cross Y diyelim. Bir tanesi kompaktsa ve orada bir tane line yani aldığımızda onu içeren open setler varsa o zaman open e, o line segment'ı kalınlaştırabilirim diyor. Ya burada da onu kullanıyoruz. Okey. Hı. Evet, bunun sonucu olarak biz ne yaptık? Yani şunu üçüncü tahtaya alayım. Ha, bu arada sınavın süresini 24 saat yapacağım. Sizin cumartesinize mal olacak ama hani 2 saatte yapıp yüklerseniz de sorun değil. Yani aslında iki saatlik bir şey de hani e, acele etmeyin diye. Ha yok, bu remark'ı boş verin. Söyleyeyim. So we have proved this fact. Okay, this is isomorphic to the set of integers. Okay, and to prove this, we used curve lifting stuff and so on. Let me just draw some pictures to see how this curve lifting works. Some examples. For example, consider the following covering. And this is mapped to the following. So this is basically the map z goes to z cubed, okay? Z cubed, and how it goes, suppose this is A and this is B. So this is A, A, A. So as you go once around this circle, you go 3 times around this one. So here, labeling means the following. As I go from this point to this point, I go along A. I label both this one and this one with the same letter to indicate that, as you go from this point to this point, you just go around A, okay, once. And here, this is B. So as you go from this point and go around B once, so that will correspond going around B. Okay. Now let's, for example, so this is a threefold cover. So this is also aynı yönde olması için nasıl olması lazım? Şöyle, değil mi? Şu B. Mesela şeye bakalım. Let gamma be the loop in, so this is, let's say, Y. This is X in Y, based at Y0. Y0'da şu nokta olsun. Y0. Find its lift. In X based at X0. X0'da mesela şu nokta olsun. Tabii ki X0 şunu sağlaması lazım. Yani bu P of X0 Y0 olması lazım. Mesela gamma'yı şu alayım. Gamma şu olsun. Bu homotopy class of şu olsun. Şöyle yazayım. Bir word olarak ne olsun? A kare B inverse. Yani gamma dediğim şey şu. Şu homotopi sınıfı, şu lift curve'in 2 kere A boyunca gideceğim. Bir kere de B'nin tersi boyunca. Bunun hangi liftini arıyorum? X0'dan başlayan liftini arıyorum. Şu noktadan. So, what we should do? I'll start from this point. I go around A twice. So, okay. This is 1A, A, and then another A. So this is A squared. And then I go around B, but in the inverse direction. So I just go like this. So the end point of the lift, so that is just gamma tilde, and the end point is this one. Okay. Başka bir tane alsaydık mesela, gamma şu olsaydı, ya da bunu alfa diyeyim. A, B, A inverse. Yani şu A boyunca gidiyorum, sonra B gidiyorum, sonra da A'nın tersiyle gidiyorum. Şu noktadan başlasaydım gene, şuradan başlasaydım, ne yapacağım? Önce A boyunca gideceğim. Şuraya. Ondan sonra B boyunca gideceğim. Yani şöyle yapacaktım. A, B. Ondan sonra da A'nın tersi. A'nın tersi beni gene buraya götürecekti. Değil mi? Başladığım yere geri dönecektim. A, B, A inverse. So you again end up at the point x0. So the lift of this one, this is not a loop, but the lift of this one is a loop. Okay. Peki. Şimdi. Oh. İki sene önce verdiğim zaman daha hızlı gitmişim. Hep öyle oluyor genelde. İkinci defa verince daha yavaş oluyor. O yüzden belki bazı yerleri hızlı hızlı geçeceğim. Buralarda değil ama daha ileriki konularda. Öbür türlü çünkü yetiştiremeyeceğim. Induced homomorphism. Okay, now let F be a continuous map of topological spaces. And x0 is a point in X, and let y0 to be f of x0. In this case, we will consider f a map of base spaces. So I will write this x0 is mapped to y0. Okay. So it's a continuous map of based topological spaces. Then this F induces a homomorphism of fundamental groups. Then F induces a homomorphism of the fundamental groups. Nasıl? Bunu F neyle gösteriyoruz? Star'la göstermişim. Bazen sharp'la gösterilir, bazen star'la. Pi1 x x0 y pi1 y0, and it is as follows. So if I take a homotopy class here, I just map it to the homotopy class of F composition gamma. Okay. Now let's see why this works. If you know about functors, actually this is a functor from the category of topological spaces. base topological spaces. So I have a continuous map of base topological spaces, and it gives me a group homomorphism. So actually, this correspondence is a functor in that sense. Şimdi note that gamma is a path in the space x0, and x0 is mapped to y0. Therefore, F composition gamma is a path at y0. Of course, for this gadget to be a group homomorphism, we have to verify several things. Like, this is well defined, and it is really a group homomorphism. So one has to check that first, this F star is well defined. Second, this is a group homomorphism. Why well defined? Well, I define this map choosing some representative. Right here, this is, so how this is defined? I take an equivalence class, and then I take a representative from that equivalence class, and I compose it by F. I obtain a loop here, and then I define this as the homotopy class of that loop. But what if I choose a different representative? Will I get the same homotopy class over there? So one has to check that. But that's easy. I mean, so proof of I. So what we have to prove is the following. If gamma 1 is the same as gamma 2 in pi 1 x0, then we must show F composition gamma 1 is the same as F composition gamma 2 in pi 1 y0. But that is easy. Nerede silgi? Burada. Okay, so here, let's say I have homotopy. This is gamma 1, this is gamma 2, and they are homotopic, right? And base point is x0, so both paths start and end at x0, and inside, so they are homotopic via F. What we do, we apply F to this picture, and I have here F composition big F. Here I have F composition gamma 1. Here F composition gamma 2. Okay, so I claim that this is a homotopy from this to this one. but that is clear. So if F is a homotopy from gamma 1 to gamma 2, then we have what? So f of S0 is gamma 1s, f of S1 is gamma 2s, and f 0t and f1t are all x0 for all t. And here, of course, for all s. But then let G to be little f composition big F, which is a map from I cross I into what? F goes from I cross I to garip bir şey yazmışız buraya. To X. So this goes to Y. Evet. Y. Then what is GS0? Well, this is F of FS0, but this is gamma 1s. So this is F composition gamma 1s. Similarly, this is just F composition gamma 2 S. Neyse, isterseniz yazayım şöyle açık açık da. Pardon. So this is F of big F S1, but this is gamma 2S. So this is just F composition gamma 2S. And similarly, G0T and G. Okay, so this is just F of F0T, but this is just X0, so this is Y0. And that is just, of course, F of F1T, which is G1T. Therefore, this shows that if F is a homotopy from gamma 1 to gamma 2, then this composition is a homotopy from this path to this path, where the endpoints are both Y0, so they are loops at Y0. So this shows that this map is well defined. Okay, so let's give a break. After the break, I'll continue.